alaikum. My name is Habibullah 2020E79. Today we are discussing lab number 1 of DSP and our instructor is Dr. Muhammad Jamil Saab. The objective of this lab is explain what digital data is and why it's important. The second one is how to create visual representation of signal which are useful in various applications. The third one is how to write scripts in MATLAB, which are sequences of commands for performing tasks. And the last one, learn how to create and use functions which are reusable blocks of codes that can be called to perform specific operation. Now, task 1. In this lab, we generate and plot a sinusoidal signal with a frequency of 1 Hz for a time interval from 0 to 1 second. You can modify the code by changing the frequency f or the time to explore different sinusoidal signal. As we know in the lab task. Now moving towards task 2. In this task, we generate and plot a sinusoidal signal with time interval 0 to 1 and frequency is equal to 0 to 1 and signal is equal to sine f2 pi. Additionally, it adds a title to the plot, labels the x-axis, time in seconds for the x-axis and amplitude for the y-axis, and set a custom axis bound for better visualization. Now define interval for both x-axis and y-axis. For x-axis we define interval from minus 0.5 to 1.5 and for y-axis we define 0.1 to 1.5. As we all see in the source code and the output is also shown. Moving towards task number 3. In this MATLAB code, multiple sinusoidal signal with different frequencies are generated and plotted in the same figure. Here the time interval is 0 to 10 and frequency 1 is 10, frequency 2 is 520 and signal 1 is sine f1 2 pi and signal 2 is equal to sine f2 2 pi. Both signal are plotted on the same figure using the plot function with different colors. The plot has a title and the axes are labeled with time in second for the x-axis and amplitude for the y-axis in the last defined interval for the x-axis which is 0 to 1 and y which is minus 1 to 1. Moving towards lab task 4. In this MATLAB code, multiple sinusoidal signal with different frequencies are generated and plotted in the same figure without connecting the dots. The two sinusoidal signal with frequencies 10 Hz and 520 Hz are generated. Each signal is plotted with dots in a different color, dot for blue and R for the red, without connecting the dots. The hold on command is used to keep current plots active so that The next plot is added to the same figure. The hold off command release the hold on the plot. The sound function is used to produce a sound based on the second signal. As we shown the output. Now moving towards task number 5. In this code, we generate random data from a uniform distribution, calculates the mean of the data, and then plots both the random data points and a horizontal line representing the mean. So n is equal to 50. Specify that you want to generate 50 data points. R is equal to rand n comma 1 generates a column vector R containing 50 random number between 0 and 1 from a uniform distribution. Plot R plots the random data point on the y-axis against their indices on the x-axis. M is equal to mean R. Calculate the mean of random data and store it in the variable M. Hold on keeps the current plot active to add more elements. Hold off release the hold on the plot. Title set the title of the plot to mean of random uniform data. Moving towards task number 6. In this MATLAB function named myFunction takes a vector or matrix as input and return it maximum and minimum values. First we define a function and declare a function named myFunction that takes in input vector or matrix X. The input variable is max element in which we store maximum value of the input and min element in which we store minimum value of the input. Max x compute the maximum value of input and assign it to maximum element. Max x computes the minimum value of input and assign it to min element and marks the end of the function. In the output we write big and small is equal to my function and we write a number which is given 43, 22, 51, 11, 03, 48 and 3. The big element and the maximum element in this array is 55 and the small is 03. Moving towards task number 7. In this task, we define our function, which is myMin, and write min is equal to x1. Starting for loop from first element to last element. If any element in the array is less than the first element, then that element we says it is min element. Then end our function. In output, we just write our array and calling our array in which is mymin is 2 as shown in the output. Moving towards lab task number 8. In this task we define our function which is mymax and writing max is equal to x1. Starting our for loop from first element to last element. If any element in the array is greater than the first element, then that element we says it is max element, then end our function. In command window, we just write our array and calling our array in which my max is 9 as shown in the output. Moving towards lab task 12. In this task, we plot two sine function in same interface. For that we use subplot with ratio of 1:2, which means one row and two column. So first of all, we define time interval from 0 to 0.5, then define random number, then writing sine function and plot x, plot y, and we get output as shown in the output. In the output, you see there are two interfaces, same interfaces. Moving towards lab task 13. In this task, we plot four graphs on the same interface with 2:2 means 2 row and 2 column as shown in the output. Thanks for watching.